Now, if you've looked up machine learning before, you know there's a lot out there. Some resources recommend learning mathematics, statistics, probability, and even more before getting started with data science and machine learning. And while these topics, they're important, trying to learn them all before getting started, getting hands-on, is like trying to boil the ocean. Instead, what we're going to be doing is focusing on building practical solutions and writing machine learning code to get insights out of data. If you're a programmer now and had some experience with Python, by the end of this course, you'll be able to use your programming skills to build predictive machine learning models. Machine learning comes in three parts: data collection, data modeling, and deployment, where you might take your machine learning model after you've gone through these steps here. Don't worry, we're going to cover this framework in depth shortly. You might take this machine learning model and deploy it to users through your application or through an API or some sort. This is what we're going to cover. We're going to cover data modeling, which means you'll be able to take a data set and apply machine learning algorithms to find insights on that data set. The steps we're going to cover is number one, create a framework. You saw a little bit of an outline of that in the previous slide. Number two, we're going to match that framework once we've gone through it to available data science and machine learning tools. This means that people have already had similar problems to what we're going to try and solve in the future in the past, and so they've created tools for those problems. So we're going to learn what tools are used for what machine learning projects. And then to learn all of this, we're going to learn by doing, by going through projects which involve step 1 and step 2 to build a portfolio to show off your work and your skills. The utmost care has been taken to focus on what matters. When I started learning machine learning, I found myself confused about what to do. Too often I'd spend too much time thinking about something instead of writing code and taking action. So we've designed this course to avoid that. Instead of doing anything and everything from scratch, we're going to be using what works to build practical solutions and at the same time learning about machine learning and data science. Now, let's take a deeper look at the framework we're going to be using. Since machine learning projects can cover many different topics, it's important to design a framework you can use to approach different kinds of problems. You can consider what we're about to go through as like a little field guide that you can use for machine learning. So when you come up against a problem, you can refer back to this field guide and go, hold on, I need to break this problem down into a few little steps. What does the field guide say? The framework we're going to be using comprises 6 steps. After working on many machine learning projects across multiple different industries, these are the steps I've found which come up time and time again. We're going to see this diagram a lot in the next few lectures, but in this one we're going to dive into each of these steps individually and see what kind of components they have. Step 1 is problem definition. Since we'll be focused on code first, practical solutions, it's important to define what problem we're trying to solve. Is it a supervised or unsupervised learning problem? Is it a classification or regression problem? Don't worry, we'll see how to figure these out in the next few lectures. Step 2 is data. Since machine learning involves using algorithms to find and learn different patterns in data, data is a requirement for any machine learning project. The question we're trying to answer here in step 2 is what kind of data do we have? Depending on the problem, there are different kinds of data. Structured data, such as rows and columns, or what you'd expect to find in an Excel spreadsheet. Or unstructured data, such as images or audio. Once we know what kind of data we have, we can start to make decisions on how to use machine learning with it. Step 3 is evaluation. Here, we'll define what success means to us. Since much of machine learning actually is experimental, you could keep going forever trying to improve your results in search of the perfect model. However, since we're practitioners, we know the perfect model doesn't exist. Instead, we begin by saying, for this machine learning real estate project to be feasible, we need at least a 95% accurate model at predicting the cost of houses. Of course, in the beginning, this evaluation metric won't be exact and will likely change over time, but having this at the start of a project gives us something to aim for. Step 4 is features. The question we answer here is, what do we already know about the data? Now, even within different types of data, there are different kinds of features. For example, for predicting whether or not someone has heart disease, you might use their body weight as a feature. Since body weight is a number, it's called a numerical feature. And after talking to a doctor, they might tell you if someone's body weight is over a certain number, they're more likely to have heart disease. There are more kinds of features such as categorical and derived. We're going to look at these in future lessons. But the premise remains. A machine learning algorithm's goal is to turn these features, such as weight, sex, blood pressure, and chest pain, into patterns to make predictions, such as whether or not a patient, we've got unique patient IDs here, has heart disease or not. Step 5 is modeling. Once you've learned a little bit about your data, the next step is to model it. And the question here is, based on our problem and data, what machine learning model should we use? Unlike other algorithms and sets of instructions you have to write from scratch, many of the most useful machine learning algorithms have already been coded for you, which is beautiful for us. Some models work better on different problems than others, and in the beginning, your focus will be to figure out the right model for the right kind of problem. Step 6 is experimentation. All of the steps we've just been through happen in a cycle. You might start out with one problem definition and find your data isn't suited to it. Then you might build a model and find it doesn't work as well as you outlined in your evaluation metric. So you build another one and you find out this one actually works pretty good. But what's important to remember is although these steps are here, those steps that we've been through in this framework, it doesn't mean that they have to be followed in order, nor are they set in stone. Consider them a rough guide. Now we've been through each of them briefly, let's look at each one in a little bit more detail.